Learning deep and unfamiliar stuff. How can we learn those things? You may be feeling like, for example, if you don't have biology background, you won't understand what a vector is, what a overexpressor line is. You read it, but nothing makes sense. If it makes sense, then next day you forget it again, and so on. Yeah, human mind is not, I think, get used to learning those things. These things are really difficult to grasp. They are abstract. So that's why during the bachelor studies, people spend like 3-4 years to learn the background of any topic. But as a scientist, we won't have that much time, and we have to understand the basics in a deep level. With a very short time, we have to understand that. So is it possible to understand something that's really unfamiliar to us, that we don't have any background on? Yes, it's possible. I will tell you from an example. Okay, so as a plant nutritionist, what we do is, one of the things we do is visualizing the methyl distribution. For this, there is a technique called synchrotron measurement. These are huge machines. They occupy all the building, and this building is really huge. The machine is similar to a hadron collider. It's a circle, very big circle. And to devise an experiment there, what you do is you contact with a scientist, and then you tell your problem and you tell him what kind of experiment we should design, and then you start to discuss the experiment. You notice immediately you don't understand the physics behind, and without understanding the physics behind, you cannot make sure you get the most out of this experiment. So you have to understand the physics behind it, but it's very difficult. Okay, so first thing you need to do is trying to find textbooks on it. So for that, a general physics textbook may work. Okay. So first, go that resource. Second, go for the reviews. Some reviews are really for the guys who entered the field new, but still they require a basic physics background, which we don't have. Okay, and then maybe you can go for the articles. Another approach to the issue, a more active approach, works much better. So for this, we have an Excel sheet, and here we always ask questions. This is one thing we have to do, and trying to find the answers. And second thing we have to do is to define the concepts. So these two should go first for the active approach. Here, for example, I have the definitions of concepts. For example, spectroscopy. I know what is spectroscopy, but it's a different thing to define it. Then you know it better. You are aware what you know and what you don't know when you try to define it. What's diffraction, imaging, X-ray fluorescence. So all these terms must be very clearly understood in order to answer these questions. And it takes time to internalize these concepts. So therefore, we have to write them very clearly what the definitions are, the definitions to understand the topic. Then we have the questions. So synchrotron device. Okay, where does the word come from? Maybe it gives some information to me. So I wrote here the question, what's synchrotron? And I have this also definition. Yeah. Then I put a video link here. This video is for very basic things. And this is what I understand from the video. So you have to watch the video actively, trying to find the answer to this question. Okay. And this is the answer I found. You will have to write it as well. Then from the video, you cut the important pictures, make you understand it. For example, these are the wavelengths of the light, and synchrotron light. For example, to see the cell, you need this infrared. To see the track, you need radio waves, and to see the atoms, not the atoms, sorry, the molecules, you need X-rays. And so this is a very nice figure, really explaining the difference between the light types and how they help you to visualize things that are smaller or bigger. And this is the main picture, like how the synchrotron light is produced. I know how it's produced. It's really interesting, but I'm not gonna give you details on that. Okay, then seeing how the synchrotrons were developed during the time. This question, okay? And the answer is here, and this picture is like an answer. These questions are so basic. To understand anything, you have to ask these basic questions. So where are the synchrotrons used? Okay, then I have these pictures, different where places where synchrotrons are used. And these are some confusing concepts. So what is X-ray fluorescence? And these are some types of fluorescence. They compare different techniques. In a review, I put this picture here. This is what I understand from that. Okay. What are the challenges? What are scientists trying to achieve? It's a very important question. Because there's always development. There's something that's done, but a lot of also effort is given, and it's very important to know what scientists are trying to achieve, because this will show you the limitations of the approach or which way you should go. For example, if you help the scientists try to achieve that thing they try to achieve, then the paper you will publish will have much more bigger impact. Okay, where do we put the sample? Is a very important question. I mean, this is a huge device. Where do we put it? Okay. Yes. So this is how to deal with complicated things that are unfamiliar to you. If you are from if you are not familiar with molecular biology, which is very abstract to many people, you have to prepare sheets like that, engage the questioning actively. Hope that helps. This is an advanced technique. If you are able to learn deep stuff, unfamiliar stuff, in a short time, you are ahead of many people, because most people don't have this abilities.